Hi, this is a quick demonstration on how to do a short path distillation, which is common in the cannabis industry when you want to distill a crude oil to a distillate. Here's a very basic setup, as you would set up in a organic chemistry lab experiment. You have a source of heat, a round bottom flask with the substance that you want to distill, and a boiling chip. And as temperature is increased, this is going into the vapor phase and reaches this thermometer, which measures the temperature at which the vapor phase is then going over into this cooling condenser. This cooling condenser has an inlet and an outlet. Here's the inlet. That's where the cooling solution would go in, and here's the outlet. And the reason why it's set up like that, because this way it works against gravity, and this cooling condenser will be constantly filled. Then the distillate is dripping into a receiving flask, and that is typically caught in a beaker that has some kind of ice water or ice, so that the substance is easily condensed. Now, a more advanced setup, which is typically used in the cannabis industry, would look something like this. So here you have your round bottom flask, larger scale, that has the crude oil in it. Then you have a thermometer that's by the side, and it's oftentimes insulated with like a thermal material like this. And so then here you have the cooling column that is then leading to the receiving flask that will have the distillate. Now, sometimes what happens is that the crude oil will have some residual, say, solvents in it, and these solvents, they will be caught in this flask because this is what's called a dry ice trap, and this dry ice trap has dry ice as well as acetone, like a slurry that brings a temperature very, very low, up to minus 70 degrees Celsius. And that cold temperature will then allow any kind of vapors from solvents to be condensed here, giving a solventless distillate. The attachments that go with the short path distillations contain typically a vacuum gauge, as well as the vacuum pump that causes the vacuum to go down, and then a cooling equipment that has either water, but typically it's ethylene glycol to prevent any kind of freezing in the lines.